Okay, finishing up with example 4 from lesson 1.1, and we were ready for part C. So we had this, if you recall, Orlando Airport, we have this function for vehicles measured in T minutes. And on A, we found out approximately how many vehicles in, 18 minutes. B, we looked a little bit at the graph. It was kind of a quick graph there at the end, but hopefully you got it. And then, so we're ready for C. What is the average rate of change of the vehicles at the departing flights over the time interval from 15 to 20 seconds? And indicate units of measure. So, notice it's asking for average rate of change, yes, on the interval from 15 to 20. So what am I going to do here?
Put 20 and 15 in.
20 and 15 in. So we're going to be looking at, I'm going to write it as V of 20 minus V of 15 over 20 minus 15. With any luck, you might still have that equation in your calculator.
No,
No?
Yeah.
I got rid of it.
I had to do my homework.
Well, and do realize you can always, you can use the others. And remember, if you're looking at a graph and something's in your way, you can always turn it off. Man, I don't even have mine in there. Darn it. So. What are we getting? Negative 3.999, then it goes 226516 is what mine is, right? With that in mind, what does that mean?
Vehicles per minute.
Yeah. And what does that represent, though? Like, put it in words.
There's vehicles leaving.
Yeah. That negative is going to indicate vehicles are leaving, right? So the annual rate of change from 15 to 20 minutes is decreasing of a rate of about 4 vehicles per minute. Okay, so I'm going to put a few words here. Annual rate of change I'm going to say annual rate of change for 15 to 20 minutes. I'm using interval notation there. Is decreasing. So somehow put into words, what does that negative indicate? Don't just tell me there's a -4, the rate of change is -4 vehicles per minute. What does that negative indicate? And the fact that it is decreasing or they're leaving, something to indicate there. So decreasing about 4 vehicles per minute. Okay. I know I'm not a huge words person in math, but with calculus we have to work at that. Okay, we have to be able to put into words. Don't just say -3.9999 feet per second or vehicles per second. Sorry, wrong problem, wrong class. Okay, and then D. Estimate the instantaneous rate of change of vehicles at t equals 18 by finding the average rates from t equals 18 to 18.1, 18 to 18.01, and 18 to 18.001. Excuse me. Same equation. You've already got the equation typed in, right? So if you recall for this first one, that means I'll be doing V of 18.1 minus V of 18, or 18.1 minus 18. We're all confident in how to use the calculators here, right? Even if it means you're typing in the equation every time, but that would get really annoying in this lesson, I think. Personal opinion there. Okay, you got some values for me? What do you guys have on the first one?
Negative 3.82344.
Okay. I just have written down the negative 4.823, but minimum, remember, 3 decimal places, right? Nothing wrong with going more than that, but minimum you've got to get 3. And that is, if not that you have to necessarily label at this point, but that is vehicles per minute, right? What about my second interval? Okay. Negative 4.803. And your third one?
Negative 4.8.
Okay, so instantaneous rate of change. You got a problem, Gracie?
Yeah, probably a really big number.
Are you in radians still? You forgot your minus sign. You see where I'm looking on top there?
In there.
Jacob can relate.
See, I did a multiplication on the one I got, like, massive number.
Yeah, that's what was happening to Jacob yesterday. He was seeing these massive numbers and he left off the subtraction sign in the numerator, which is exactly, seems to be a common theme. You're in degrees? You are in degrees.
I changed it.
Yep, so you need to be in
This
radians.
this one.
But we need to be in
I
radians.
was in radians, yeah.
You know, I've never seen the smiley faces from this side of the ring. Because I've always been on that side. And they look a lot different. Oh yeah, I've always been on that side.
Oh, my poster looks different. If
Oh,
you're on the
yeah.
opposite side of the
I
room.
wondered what this side was like. I don't remember what it was like over there.
Okay. Instantaneous rate of change at t equals 18 minutes is approximately what? What would you say is going on here? Huh?
0.8. It's getting closer to 4.
Okay, yeah. And I would use the word decreasing again, okay, as opposed to just saying negative. Decreasing, and I could be led either way here because I have written down decreasing at about 4.801 vehicles per minute. And I'll be honest, while you guys were working, I went and did the next one. And the next one would still round to negative 4.801 though. So, you know, make sure your work supports it. I do get it. It is going probably towards negative 4.8. But since we haven't gone that far, you know, it can go either way there. So. Did I spell that right? Yeah, my S just went wonky. So decreasing at a rate of about 4.801 vehicles per minute. Again, it doesn't have to be those exact words, but something along those lines. And I do, you know, I'm not going to argue, Jacob. I bet it does go to negative 4.8 soon. Okay, one more. E. Why can't the instantaneous rate of change of traffic in the departure lane with respect to time be calculated using the method in Part C? So instantaneous rate of change, we just did it as we were approaching, getting very, very close. We talked about this concept yesterday. It's the same thing we talked about earlier in the lesson. Why can't we just use this method we did in Part C? It's a specific moment, and if it's a specific moment, what would the setup be?
Something over 0.
Yeah, and actually, in all reality, because on bottom it would be 18 minus 18. On top, it would actually also be 0, because you'd be doing the function at 18 minus the function at 18. And so for that reason, you would end up with 0 over 0. Now, as we go farther in calculus, we'll talk about that being something called an indeterminate form. And we'll work with ways to find limits that have that indeterminate form. But it goes back to the same thing we said yesterday. Division by 0 would occur. And division by 0 is bad enough, but on top of it, you'd have 0 over 0. Okay. I'm going to stop this. We can talk